Okay everyone, welcome to the first video example for ENGR 340. How this is going to work is you're going to be given some example problems on the lecture notes, and I'm just going to provide some accompanying videos of me solving these solutions to go with the notes, which of course you also have solutions in the notes. This is just one alternative form of getting the exact same information. Okay, so our first problem of the semester is going to be a unit conversion problem. We've got 60 grams of calcium chlorine being added to a flask. Then water is added to bring the total volume of the solution to exactly 1 liter. Assuming no transformations take place, what is the concentration of calcium chloride in units of molarity? Okay, so let's start this problem with something we do know. We can really easily find the mass concentration of calcium chloride because we know that we have 60 grams of the sample in 1 liter of water. Okay, let's take a step back really quick. Remember our notation that a mass concentration is always going to be represented by concentration C, subscript, whatever the concentration, whatever the mass is we're trying to find the concentration of. So in this problem, we're told it's calcium chloride. If you don't know the molecular formula for something off the top of your head, just Google it. So calcium chloride is always going to be written as CaCl2. So 1 molecule of calcium, 2 molecules of chlorine. Okay, so our mass concentration is just 60 grams of CaCl2 added to 1 liter of water. So this gives us 60 grams per liter of calcium chloride. Okay, so now what we need to do is find some sort of relationship between the mass concentration and the molar concentration, which is molarity. So if you look back a couple slides, we're given this relationship. Mass concentration is equal to the molar concentration times the molecular weight of the molecule. And this has to do with mass fraction, which isn't part of this problem, so we don't have to worry about that. So let's go back to the problem we're working on. So this states that CaCl2, calcium chloride, is going to be equal to the molecular weight of calcium chloride times the molar concentration of calcium chloride. So remember, we use these bracket notations to denote a molar concentration, mass concentration, molar concentration. Okay, so we can rearrange this to find CaCl2 molarity is equal to the mass concentration divided by the molecular weight of CaCl2. Okay, so now we know, oops, that's not what I meant to do. We know this, we just found that out. That's the 60 grams per liter. This is some known constant that we can just Google. So we just need to find the molecular weight of calcium plus 2 times the molecular weight of chlorine, and that will give us the molecular weight of calcium chloride. So let's do that. Now I Googled this ahead of time, so I know that the molecular weight of calcium chloride is equal to 1 times the molecular weight of calcium, which is 40.078, plus 2 times the molecular weight of chlorine, which is 35.4527. Okay, so that equals 110.98 grams per mole. Okay, so again, this 40.078 is the molecular weight of 1 molecule of calcium. This 34.4527 is the molecular weight of 1 molecule of chlorine. So since we have 2 of them in this problem, we have to multiply that by 2. So then the molecular weight of calcium chloride then is 110.98 grams per mole. Okay, and the last step is just plugging that all in. So now we just found the molecular weight. We know the mass concentration is 60 grams per liter. We've got grams divided by grams. So here, let me just write this. So this is going to be 60 grams per liter over 110.98 grams per mole. Grams cancel with grams, so this gives me a total of 0.54 moles per liter, which is equal to big M for molarity. Okay, so here is our answer right here. All right, and then if we had milligrams instead of, so if we had 60 milligrams instead of grams, you would have to make sure to convert milligrams to grams to make it consistent with the molecular weight. But that's all we're doing to convert mass concentration to molecular concentration. No, sorry, molar concentration. It was real good right till the end there.